Yes, good morning, friends. Friends, welcome to the session once again. How are you? How is your preparations going on? Yes, a very warm welcome to the session once again. Today we are going to have the fifth session under climatology. Okay, fifth session. We have already covered the basic structure of the atmosphere, the basic composition of the atmosphere, various temperature and insulation characteristics, even looking at the isotherm and the temperature characteristics in different regions. Also, we have seen the Coriolis force. Along with this, we have seen the pressure pattern of the world. Okay, and yesterday we have ended our session with the tricellular circulation. That is the vertical aspects also. The upper air circulation also we have seen yesterday. Today we are going to see more on the shifting of the pressure belt and how it influences different wind system. Okay, the entire wind system in the world can be broadly classified into three. That is the planetary wind, the secondary wind, and the local winds, which we are going to see one by one. Okay, before we begin the session, let me tell you one thing. In the middle of discussion, if any one of you not able to follow anything, you can interrupt me at any time and you can signal that in the live chat box below. Okay, I will be happy to clear your doubt n number of times. Anyways, before we begin with the session, I have some important information to be met from the platform. That is, you see here, these are the successful candidate, the latest successful candidate in UPSC exam. Now, there were within all India rank 1 to 20, there were somewhere around 7 learners who took the course which was started in Unacademy last time, that is the last mile program. Between 21 to 100, there were around 20 learners. Around 100 rank, all Indian rank 101 to 761, there were around 143 learners. Therefore, Unacademy comes up with, depending on the exam, whether it is a prelims exam, mains exam, according to the exam, we come up with from the Unacademy platform different programs. So if you also wanted to be a part of this successful list, you can always enroll. Okay, one is this compo, the expected price hike, one which has happened already the day before yesterday, that is on 9th of December. Another is going to happen on 16, and after that very soon another mega price hike will be there. Therefore, what are you waiting for? Kindly subscribe to this so that you get a substantial amount of discount. Okay, if you at all require, you can use my code SUNEP10. Similarly, there is another program known as Plus GS. Here also similarly, the price hike is going to be very soon. So before the price hike, kindly subscribe for this program also. There is one subscription that is known as Iconic subscription. You can level up your UPSC preparation with this. In what ways? One-to-one life mentoring you will get. You will get just like a personalized coach. At the same time, you will get this study planner every bi-weekly. Okay. Also, nothing like practicing for your prelims through MCQ. There are 2-3 important things. One is, when you practice MCQ in a program like UPSC CSE Compact, which happens every Sunday, that is tomorrow at 11 AM, 56 question in 60 minutes, you are getting a huge amount of scholarship from a pool of around 4 crores of rupees. It is available both in English and Hindi. Now, 2 important points you see here. Apart from the reward that you will be getting, scholarship and all, you see here, by attending such a MCQ competition, firstly, you will know at what level of preparation you are as compared to your peer group. Therefore, it gives a very good opportunity for self-assessment, which is very, very important. Okay, why? Because UPSC exam as such is no more a university or a college level exam. It is a competitive exam, which means there is no pass mark as such. It all depends upon your relative mark as compared to your peer group. Therefore, by attending such a UPSC compet, because anybody who will be sitting for this test or competitions are, you know, kind of your friends only, the aspirant of the UPSC civil service. Therefore, you will know at what level of preparation you are. So, for the self-assessment, what is better than such a test? So, you kindly attend. It is only for one hour. You can use my enroll code, that is SUNEP10. Okay? Chalo, with that basic introduction, let us continue with our discussion of today. Clear? Chalo. Yesterday we have seen this particular diagram. I have shared this particular diagram with you yesterday. That is shifting of the pressure belt. Okay, we have seen this diagram yesterday. Shifting of the pressure belt. Now, we have seen the basic characteristics of this. That is, why this shifting of the pressure belt? Say for example, I have a sun here. The apparent shifting of the sun insolation to the north as well as to the south depending on the season. And since the sun insolation and the pressure belt on the earth's surface is directly correlated to each other, whenever there is an apparent shifting of the sun insolation north or south, the pressure belt will also change. Yesterday we have seen how a pressure belt changes. You see here, during June, that is during the summer season in the northern hemisphere, the pressure belt moves up like this. You see here, kindly follow the pointer. In the March and September, that is when there is an equinox in the equatorial region. That is, equinox is nothing but when sun insolation is directly at 90 degrees over the equator, that is known as equinox. The equatorial low pressure belt is like this. This line is equator. In the winter season, the low pressure goes down to the southern hemisphere like this. And all the other pressure belt also get shifted accordingly. And the shifting is considered to be completely parallel like this, horizontal. Clear? Now the significance of shifting of this pressure belt is, when a pressure belt changes, the direction of the wind also can change. Why? Because we know wind blows from high pressure to low pressure area. So whenever a shifting of pressure belt is taking place, the wind direction gauge changes. Therefore, when the wind direction gauge changes, the climate and weather phenomena of that particular specific place also get changes. We will discuss in detail later, but let me tell you one thing. There are different climatic conditions in the world. Say for example, in India, we have this monsoon type of climatic condition, which is we have rain in the summer, dry season in the winter. Now all the part of the world does not enjoy the same type of climatic condition. Say for example, in the Mediterranean type of climatic condition or weather phenomena, there is rain in the winter season, dry in the summer season. Clear? All this rain in the winter season is because of shifting of this pressure belt. Clear? But one very, very important point is, you see here, yesterday also we have seen this. This shifting of the pressure belt, which is completely parallel and horizontal, does not take place in real life. The reason is, just for the sake of explanation, that we have considered shifting of such a pressure belt, okay, on an idealized earth surface, that is homogeneous earth surface. If the earth surface was homogeneous, which means if the earth surface consists of only water all throughout the earth surface, or if it consists of land area or land mass all throughout the earth, then shifting of the pressure belt would be horizontal, up and down like this. But in real, what you will observe is in the Earth's surface, it is not homogeneous. In some region you have water body, in some region you have land mass. Also remember, we have already seen isotherm. We have already seen isotherm, and also you know that the specific heat of land and water is different. Therefore, what is the specific heat? The amount of heat that is required to increase a unit by a unit of temperature, that is known as specific heat. Now, specific heat of water is much higher as compared to land area, which means it requires more energy in order to raise the temperature of water as compared to the land. Or I can say it requires longer time for the increase water temperature as compared to the land for the same unit. Now on the other hand, it requires more time for the water to cool down compared to the land area, which means the land area heats and cools at a faster rate as compared to the water body. So you consider this, Earth is not homogeneous. The specific heat of land and water are different. So depending on that, in real life, the shifting of the pressure belt, rather than occurring horizontally or parallel to the equator like this, in real life it occurs like this. You see here the diagram or the graph which is in front of you, you can see. In real life, in actual, it happens like this. Till now, in your GC Leong or in your other NCRT books, you must have already seen this kind of a pressure belt shifting. But this is just for the sake of understanding that they have given this one. But in real life, the change in the pressure belt or the shifting in the pressure belt happen in this way. You kindly follow the pointer and let me tell you here. You see here. In this particular region of the world, that is over the Pacific Ocean, you see here, it is July and January, means different season. Okay, approximately half year difference. You see here, at this particular region, since it is a homogeneous region, if you consider this small region here, and it is composed of a homogeneous body, that is water body over the Pacific Ocean. Therefore, here in this region, the shifting of the pressure belt will not be substantial. Okay, why? Because the specific heat of water is high. But you come here to this Eurasia region, Africa and Eurasia region. Here you have large chunk of landmass. Therefore, the shifting of pressure belt is quite prominent in the Indian subcontinent or in the Eurasian region like this. During the summer, the pressure belt shifts up to even 20° north latitude or more, like this you see here. And during winter, again, it goes down like this. So, the shifting of pressure belt is not uniform all across the world. In a region, homogeneous region like Pacific Ocean, the shifting is not prominent. Yes, there will be some shifting, there is no doubt about that. But the shifting will be quite negligible. On the other hand, in a place where you have large land mass like Eurasia, the shifting will be quite prominent. You see here, shifting of pressure belt during December and January, intertropical convergence zone, also known as ITCZ, which is responsible for monsoon in India, is here. During June and July, you see here, it comes even up to the northwestern part of India like this. So this is the shifting of the pressure belt that is happening in the real life. Clear? So be very important. These are very important. Okay. If you don't understand this, if you are still within this school level understanding of shifting of pressure belt horizontal, it will not work. You will have to graduate yourself, or you will have to migrate yourself or upgrade yourself in what is happening in the real world. Now, let me tell you again the significance of shifting of such a pressure belt. You see here, when this intertropical convergence zone is in this region, wind is blowing like this, you see. But when the intertropical convergence zone, that is shifting of pressure belt, happens in this region, the wind reverses its direction. Now, reversing of the wind from one direction to the other has lot of climatic and weather phenomena significance. Clear? Laurel Sinkledon, good morning and welcome to the session. How are you? Clear? I hope that is clear. Now, we already have seen what is the significance of pressure belt. Pressure belt is important. Why? Because by studying or by identifying certain pressure belt, we are able to understand the wind circulation. Okay, wind circulation. Why? Because wind will blow from high pressure region to low pressure area. Now, entire wind that you will observe in the world can be broadly classified into three. That is primary wind, secondary wind and tertiary wind. What is this primary wind? Okay, you see here, kindly follow, very important. The entire wind that you find on the planet Earth can be broadly classified into three: primary, secondary, tertiary. What is this primary wind system? It can also be called as prevailing wind or permanent wind. As the name suggests, permanent wind in a sense, this particular wind system will exist over the Earth's surface all throughout the year. Okay, all throughout the year it will be present. Example, the trade wind, the westerlies and the polar easterlies. On the other hand, the secondary wind or the seasonal wind, as the name suggests, seasonal means it does not exist over the Earth's surface all throughout the year, but in some season it will be there and in other season it will be completely missing. That's why it is known as seasonal. Say for example, monsoon wind. Monsoon happens during the summer season, and this monsoonal southwest monsoon disappears or changes the direction during the winter season. So monsoon is a type of a seasonal wind. Cyclonic circulation. Do you think that the tropical cyclone which happens in the tropic of in Indian Ocean and in the Arabian Sea happens all throughout the year? No, it happens only during the summer season. It does not occur in the winter season. Clear? Similarly, the hurricanes in the US region. Okay, so these are monsoon, cyclonic circulation, air mass. They come under this seasonal or secondary wind system. Finally, but not the least, you have third type of wind system, which is known as tertiary or local wind system. Tertiary or local wind system is the wind system occurring in a smaller place because of some local conditions. It is known as tertiary or local wind system. Let us go and see one by one. Planetary wind system, you see here. Wind in the tropics, that is 30-degree north and south latitude. These are the trade winds that you will find. Okay, you kindly focus here only. The yellow color wind and this brown color wind. These are the wind. Now I am not explaining you about why this wind is generated, how it is generated and the direction, because we have already discussed about that. Coriolis force, from subtropical high pressure to equatorial low pressure, the wind will flow, but during this movement it comes under the influence of Coriolis force. So like this in the northern hemisphere, like this in the southern hemisphere. Now one very very important point that you need to know is, whenever a wind is blowing like this, when it hits the coastal region, then they are supposed to bring moisture laden wind to the coastal surface. When it is blowing away from this region, okay, when it is blowing away from this region, you see here, whenever a wind is blowing over the water body, the upper part of the water is also carried along with the wind, depending on the wind speed. But one very important point is, you see here and you see here. It is a coastal region. Wind is blowing off the shore like this. Wind is blowing off the shore like this, which means in this oceanic region, the water is carried forward along with the wind. Clear? When the water is carried along with the wind, there is a vacuum which is created here, right? This is a coastal region. This is a land area. The wind is blowing away from the coast. So when the wind is blowing away from the coast, the top layer of the ocean water is also carried along with it, which means leaving behind some type of a vacuum. See, let me explain to you like this. This is a land area. The water is blowing like this. The wind is blowing like this off the shore. The top layer of the ocean water is also carried along with this. Vacuum is created. Now, from where this particular vacuum will be filled, this water cannot come. Wind is blowing like this. In order to fill this vacuum, a water from below comes up. In oceanography, whenever there is a vertical upward motion of the water, it is known as upwelling. In the upwelling process, the water which is below, they are very cold, they are nutrient rich, they are oxygen rich. Therefore, a water which upwells, bringing fresh nutrient, fresh oxygen, cold water, this region becomes a very, very important region for breathing of marine organism. Therefore, here in this Peru, Chile region, you have a very good fishing ground. Similarly, you have a cold current here. You have a cold current here also in Pinguila's cold current. So, see, that is the point which I want to highlight here. Yes, the trade wind is there, but see, you are preparing for competitive exam. Remember, you are no longer a school or a college student. You are appearing a competitive exam. Therefore, the wind in the tropic, just to know that it is a trade wind which is coming, and because of Coriolis force, that is not enough. You need to know what is the implications of this trade wind in the region. That is important. Therefore, I have given you this one implications. There are other implications also. Because of paucity of time, I won't be able to explain everything in detail in this class. But if you are interested, I have a plus course under Unacademy platform. There we have sufficient amount of time, and also there we have very good tools in the platform where we explain everything thoroughly. Okay, so you can always come and join me there. One very, very important concept about this particular trade wind is known as hook trade. What is this hook trade? You already know what is hook trade. Okay, I will assume that you already know what is hook trade. You may not know the term that it is known as a hook trade, but you know the wind system. And that is, you see here. Kindly follow. This is equator. Does the equator location changes? It changes or not? Any one of you? Does the location of an equator changes? That is first question. The second question, does the location of pressure belt changes? Yes, the pressure belt changes. Shifting of the pressure belt as per the apparent shifting of the sun insolation. Does the equatorial place changes, location changes? No. Equator will always remain in the equator only. Okay, it is a silly question. But the pressure belt changes. But there is an important point why I have asked you this question. That is, many of the aspirant or the learner assumes whenever the pressure belt is changing, they just assume. If I ask you a question separately like this, then you will say the correct answer that equator location does not change. But most of the aspirant consider whenever a pressure belt changes, it is as if with respect to the equatorial region, but it is not. You see here, the pressure belt can change here and there. Okay, but the equatorial location remains fixed. Now the most important point is you have this Coriolis force. Now this Coriolis force is nothing to do with the pressure belt. Coriolis force is everything to do with the equatorial region. Coriolis force is zero in the equator. It increases if you go northward or to the southward. Clear? Now, therefore, you tell me, during the IT season, during the monsoon system, that is summer season in the northern hemisphere, the pressure belt will shift towards the north. Clear? During the northern summer season, because of apparent shifting of the sun, the pressure belt will move towards the north. Clear? Now, therefore, I assume, and just now we have seen how in actual the pressure belt, that is the equatorial trough, which is also known as ITCZ, intertropical convergence zone, will go to the northern hemisphere like this. So consider it is the new ITCZ or pressure belt here, from equatorial low pressure because of sun apparent shift to the north during the summer in the northern hemisphere. This pressure belt has went up like this. Now, whenever a wind from the southern hemisphere is moving like this, a trade wind, when it comes to this equatorial region, suddenly it will find that the low pressure area is no more in this region, but rather the low pressure area is over this one. Now, you see here, the wind always blows from high pressure to low pressure. So this wind will continue to flow, searching for the low pressure area. But you see here, the moment it crosses the equator, since it is in the northern hemisphere, the Coriolis force influences the direction of the wind by shifting it to the right in the northern hemisphere, and it shifts towards the left hand side in the southern hemisphere. So in the southern hemisphere it was shifted in this direction on the left. That's why the wind was blowing like this. But soon after it reached this equatorial region, this particular wind will realize the low pressure is not here. Low pressure is somewhere up here. Therefore, it will continue its journey. So the moment it continues its journey, the moment it enters the northern hemisphere, this wind will be tracked towards the right because it is in the northern hemisphere now. It has crossed the equator. Therefore, it will curve like this, becoming southwestern direction. That's why we call it as a southwest monsoon wind. This is nothing but this is also a trade wind originating from the southern hemisphere, reaching to the northern hemisphere because of shifting of the pressure belt, and it looks like a hook of a fish. That's why it is known as a hook trade. That is very, very important. Clear? Let us quickly go. The westerlies. Westerlies, simple, from the subtropical high, a wind which is blowing towards the upper latitude like this, it is known as westerly. Now, important point is, this westerly wind is more severe in the southern hemisphere as compared to the northern hemisphere. That is one point which I wanted to highlight. See, you may not want to listen this, but let me tell you again and again. You are no longer in college nor in university. You are trying for a competitive exam. Therefore, just by knowing that the subtropical high is there, subpolar low is here, so a wind is blowing like this, because of Coriolis force, it is tracked towards the right, the direction is changed accordingly. That is not enough. Remember, trust me. It is important to know some of the important characteristics of this wind system. Regarding the trade wind, I have just mentioned to you the cold current here and here in this region. What is the significance of this? Similarly, this westerly, one important observation that you can do is, it is more prominent in the southern hemisphere as compared to the northern hemisphere. What is the reason? The reason is, in the southern hemisphere there is less land mass. Therefore, this particular westerly can travel for a very longer distance without any obstruction. They are called as roaring 40s, furious 50s in the southern hemisphere. Okay, that is the planetary wind. Okay, planetary. See, you kindly go and see the polar easterly wind also, another planetary wind. Okay, regarding the secondary wind system or seasonal wind system, which are cyclones, okay, air mass, we will deal later. So now let us go to the third type of wind system, that is the tertiary or the local wind system. Okay, now you see here. The first in the local wind system is land and sea breeze. Kindly observe the figure in front of you. I have one important question to ask with you. Okay, and it is important from your exam perspective. Again, let me tell you one thing. as far as your exam is concerned, it is not only the mechanism like in daytime, sea breeze, nighttime, land breeze, it happened in this direction, that is not sufficient. There are other important factors. Now you tell me, when will be the most minimum intensity of land and sea breeze? Or at what time of a period, at what time of the day, or 24 hours, day and night, will the land and sea breeze will be minimum, intensity will be minimum? Or in extreme cases, or hypothetically, just for the sake of understanding, will be zero? That is my question. It can be a very good MCQ question in your prelims. At what time of the day, in 24 hours, the land and sea breeze will be minimum intensity? Okay, there can be a question like that. Now, another question can be, in temperate zone, what is the nature of land and sea breeze? In higher latitude, what is the characteristics of the land and sea breeze? So three important questions can be derived from here. Okay, so now you must be very, very comfortable, like by saying that the land and sea breeze is very simple. What is the need of studying land and sea breeze? These are very simple. Even at the midnight hour, at midnight, anybody can wake me up and ask me, I will explain. That's why I'm asking you three important questions which is related to the land and sea breeze. Now you kindly answer. The first question is, at what time of the day, that is in 24-hour period, will the land and sea breeze intensity will be minimum? Yes, anyone? You see here, let me give you the basic understanding of land and sea breeze. It is sun. During daytime, because of the less specific heat of the land as compared to the water, land will heat up faster. When the land heat up faster, the air over this will be heated up faster. It will be warm, it will become light, therefore it will go up. On the water, therefore a vacuum is created. Similarly, the water body, it will, specific heat is much higher, so it will warm up slowly. Therefore, it will having low temperature as compared to this. Therefore, a wind will start to flow like this. From relative high pressure will be here and low pressure will be here, and it will end the circulation like this. This wind system is known as sea breeze. Exactly at night, when you have a moon here like this, what will happen? Cooling will happen. Now, during cooling, specific heat of water is much higher as compared to land, so the land will cool faster. When the land cool faster, the temperature over here will be much cooler as compared to the temperature at this. Why? Because the water will cool slowly. Specific heat is much higher. So water cools slowly, warms slowly as compared to land. Therefore, relative high pressure created here, relative low pressure created here. This is nothing but the land breeze. Clear? Now you tell me. This is the simple mechanism of what is land and sea breeze. Now you tell me, at what period of the day in 24 hours will there be minimum intensity of this land and sea breeze? During morning and evening. When the temperature, see, during morning and in the evening, the temperature difference between the land and sea is minimum. When the temperature difference between the land and sea is minimum at this particular morning and evening, the wind velocity will also be less. Wind velocity less means less intensity of the sea and land breeze. Clear? Imam McBride. Good afternoon, good morning and welcome to the session once again. If you have any doubt regarding any point, you can kindly go ahead and ask me. But I still wonder, what is this writing? You guys are writing VOT. FYI, I know. What is this VOT? Kindly elaborate. On the other hand, you see, in temperate zone, okay, in temperate zone, that is higher latitude. in temperate zone, sea breeze in summer, there is no substantial land breeze you will find. What is the reason for this? Sea breeze in the summer. See, if you just imagine the globe, okay, just imagine the globe. Now, in the northern hemisphere, okay, in the northern hemisphere, you have substantial amount of land. Now, the higher you go, the temperature reduces. In the equatorial region, temperature is maximum. You go towards the polar region, temperature reduces. In the temperate latitude, what happens is there will be a sea breeze in the summer, which means in the summer, the land will be heated very substantially in this temperate latitude. Therefore, from the ocean region, a sea breeze will be there towards the land in the summer. But there won't be that much substantial land breeze. See, for the land breeze to happen, what is the condition? Land breeze to happen, at night time, the temperature of the land should fall. Okay, and the temperature over the water should be, okay, a little bit higher. But since it is in the temperate latitude that is higher up in the latitude, the temperature is not, difference is not much during the night time. Therefore, there won't be no substantial land breeze in the temperate latitude, but yes, there will be sea breeze in the summer season in the temperate latitude. Now, Colin Webster, good morning and welcome to the session once again. What will be the characteristics of a land and sea breeze in the higher latitude? There won't be any substantial land and breeze in the higher latitude that is near the polar region. The reason is in the polar region, the wind gets shifted. There are many local winds. Therefore, frequent shifting of the pressure belt in this region will not allow any substantial land and sea breeze to take place. That is the first type of local wind. The second type of local wind is mountain and valley breeze. Okay, it is also mountain and valley breeze also is a type of local wind. Okay. Now, what is this particular valley breeze and mountain breeze? Okay, you kindly follow the pointer you see here. Very simple, you see here. I will draw a horizontal line like this at the same altitude. Okay, kindly follow the pointer. Now you see, I will consider some parcel of air. Let me consider this as one parcel of air, another parcel of air, another parcel of air. Let me name it 1, 2 and 3. Now you tell me which during the daytime, okay, daytime, a heating is taking place. Sunlight is there, heating is taking place. Now you tell me which parcel of air, that is air number, parcel number 1, parcel number 2 and parcel number 3, this air parcel is in contact with the land area like this. Okay, now which parcel of area will be heated much faster? It is the parcel number 3 which will be heated much faster as compared to air parcel 1 and 2. The reason is very similar. Like heating and cooling of the land is much faster as compared to the water. Similar example, it can be applied here. Here, this air parcel number 3 is in contact with the land. But this air parcel 1 and 2 is not in contact. So the heating of this particular air parcel number 3 will be much faster. When it is much faster, what will happen? It will be heated. Once it is heated, it will become light. When it becomes light, it will move up. Now, similarly, in all of this slope, you have the same heating which is taking place. But at the same time, at the same altitude, the air is not heated at this rate, means these are colder. So this heated air will be moved upward like this. Now a vacuum which is created here will be filled up by a cooler air having higher density. It will come down like this. So this upward motion of the wind up the slope during the daytime is known as valley breeze. Clear? Colin, Paula, Ruth, Robinson, good morning and welcome to the session once again. Clear? This is known as valley breeze, or it can be also known as upslope wind, or it is also known as anabatic wind. Now, it is very, very important for any kind of competitive exam that you know by different name. Okay? Don't ignore the other names. In exam or in any kind of test, a question can come from any of the alternative name. So it is very important you know the alternative name also. Therefore, this is known as a valley breeze or upslope or anabatic wind. It will result in the formation of a cumulus cloud, sorry. Clear? Now, what is this mountain breeze? Now, similar example, I draw a horizontal line like this. It is during night time or during a winter season, you can say. Now you tell me, similar practice, parcel of air number 1, number 2, number 3. Now you tell me, which parcel of air at the same altitude, height, will be cool faster? Parcel number 1, 2 or 3, which one will be cool faster? It is the air parcel number 3 which is in contact with the land area will be cool faster. When it is cool faster, what will happen? Cooling means the air becomes heavier. When the air becomes heavier, it will come down. Now at all of this slope, such a cooling is happening. So it becomes heavy, therefore, and you compare it with the same altitude. These are warmer, so lighter. These are heavy, so it will come down the slope like this. Such kind of wind is known as mountain breeze or downslope or katabatic wind. Yeah. Now, it is important for farmers or cultivators. That's why usually the plantations or farmers doing the cultivation, usually in this kind of a region, very cold region, they don't cultivate their food crop or plantation crop right at the bottom or the valley, but rather on the slope only they cultivate. The reason is, if they cultivate the crop like this, because of this mountain breeze or katabatic wind, ice-laden wind also comes sometimes and it will destroy the crop. That is the reason. Clear? So this also comes under the local wind. Now, these two are the important local wind, that is land and sea breeze, mountain breeze, katabatic wind and anabatic wind that we have seen. Remaining local winds can be broadly classified into two. That is warm hot wind, hot local wind, cold local wind. Okay, we'll end the session here today. We will continue tomorrow, that is on Monday. Okay, same timing, 11 to 11:40. Okay, anyway, thank you so much for your patience and cooperations. We will meet again on Monday at the same time. Okay, bye bye and take care and happy weekend to all of you. Okay, bye.